Hello students, welcome to Young Cubs. We are continuing the chapter Trigonometry and we are solving this sum. In the following table, a ratio is given in each column. Finding the remaining two ratios in the column and find the remaining two ratios in the column and complete the table. What is a column, children? A vertical grid. This is one column, this is the second one. So each column out here is a sum. Alright? So this is my first sum, second, third, fourth, fifth, sixth, seventh, eighth, ninth. So today we are going to do 9 sums. Alright? For convenience and for better understanding, children, I have written each value on a different page. Along with that, I have drawn a triangle so that I can explain better. So this is my triangle ABC. My B is a right angle triangle and I'll take C as theta. Alright. So the value of cos theta is given, which is 35 upon 7. So what if cos is given? What's the rule for cos? It's ka. Correct. What's the rule for sine? It's so. What's the rule for tan? It's toa. Correct. So for ka, what is the value? What do we write? A means adjacent upon hypotenuse. Correct. What's my adjacent to this angle? This is my adjacent to this angle. And what's the hypotenuse? AC. Correct, is my hypotenuse. Right. So, but my value of ka is given, which is 35 upon 37. That means my adjacent value is 35. My hypotenuse value is 37. Correct? Now children, remember these values are in their reduced form. Okay, that means there must have been some number that has been multiplied with them and then they are reduced and then they've arrived to a number which is 35 upon 37. Alright, so let the number be x. Alright. Okay, so my hypotenuse value is 37x and my adjacent value is 35x. Alright, so I have my adjacent, I have my hypotenuse, but what about my opposite to theta? I have to calculate that. So whenever you think of a right angle triangle, the first thing that comes to mind is the Pythagoras theorem. And what is my Pythagoras theorem? It is hypotenuse is equal to one side plus the other side. Correct? So my hypotenuse is what? AC the whole square is equal to AB the whole square plus BC the whole square by Pythagoras theorem. Alright children, what's my value for AC? My value for AC is 37x. So 37x the whole square. What's my AB value? Nothing. Let me write opposite out here. My opposite value is not given, so I'll let this be. And my BC value, which is here, which is my adjacent, is 35x and the whole square. Right? When I bring 37x, when I take this on the LHS as 35x the whole square, I get my AB the whole square. Correct? Now, doesn't this look like a square minus b square? Yes, it does. So, what is the identity? A square minus b square is equal to a plus b into a minus b. Correct? Yes, children. So, going by that identity, instead of 37x square minus 35x square, solving it, removing the squaring it up, and then subtracting, the numbers become really large. So it is an easier way to do it with this identity. A plus, what is my b value? This is my a value, this is my b value. So what's my b value? 35x into 37x, that's my a value, minus 35x. Alright, that will give me my ab square. Correct? So 37x plus 35x is 72x into 37 minus 35 is 2x. ab square. Correct? So 72 into 2 is 144. X into x is x square, which will give me my ab square. So if I have to, now what I'm going to do? I'm going to apply square root. Apply square root on both sides, and it becomes AB. Okay, square root as in remove the square. What is the square of 144? We know it's 12. X will remain. So what's my value for AB? Out here it is 12x. Yes, children. Okay, so now let's apply so and toa. So for so out here, for so, as in if I have to find out sine theta, I'm going to apply opposite upon hypotenuse. What's my opposite value? It is 12x. What's my hypotenuse value? 37x. Yes, x cancels. What's my sine value? 12 upon 37. Should I write it here? It's 12 upon 37. Right? How will I find my tan now? Tan theta will be toa. Toa means opposite upon adjacent. Correct? What's my opposite value? 12x. What's my adjacent value? 35x. Remove the x. 12 upon 35. That is my value for tan. Was this easy? Yes. So you have to apply the Pythagoras theorem as well and the SOHCAHTOA rule as well. Got it, children? These sums are in 2 steps now. Hope you've understood this much, children. Let's move to the next sum. Here it is. Here a sine value is given. So what are we going to do for sine value? We're going to apply so. Yeah. So sine is equal, sine theta is equal to opposite upon hypotenuse. Let me name this as ABC again. You can name it as anything, children. This becomes easier for me. Hence I write ABC always. So sine theta opposite AB is the opposite side. Correct. BC, no. I need hypotenuse, which is AC. Now sine value is already given, which is 11 upon 61. Obviously these numbers are in the reduced form, so I'm going to add the x. Alright, so what's my AB? opposite side, which is 11x. This is my opposite, and it is 11x. What is my hypotenuse? It is 61x. We have to find BC. Similar thing by Pythagoras theorem. So 61x the whole square is equal to AB. AB is 11x the whole square plus BC the whole square. Why did I do this? Because I applied Pythagoras theorem, right? Again the same thing, 61x the whole square. This comes on the other side, becomes minus 11x the whole square, which is BC the whole square. Correct? So by identity, a square minus b square is equal to a plus b into a minus b. Correct? So this is my a value, b value. So a plus b. So 61x plus 11x and 61x minus 11x will give me my BC square value. So 61 plus 11 makes it 72 again into 61 minus 11 makes it 50x, right? Which will give me my BC square. 72 into 50, and I'm just going to write 5 and I'll add the 0 later. 5 2s are 10, 5 7s are 35, 36 and another 0. Alright, so 3600 x square will give me my BC square. Going by, now what I'm going to do is square root both sides. So after I square root, I'm also going to change the sides, which is BC on this side will become, what is the square root of 36? It is 6 and 2 zeros become 1 0, and this is going to become x. So what's my value for BC, children? 60x. That's my adjacent, and which is 60x. Correct? So now, simple. Now I need to find cos and tan. How will I find cos theta, which is opposite? No, which is adjacent. Adjacent upon hypotenuse. What is my adjacent? 60x. What is my hypotenuse? 61x. X cancel. 60 upon 61 is my cos theta value. 60 upon 61. What's my tan value going to be? Tan theta is opposite upon adjacent, OR. My opposite is how much? 11x. What's my adjacent value? 60x. X's cancel. My tan value is 11 upon 60. Here we go. Children, the entire table is based on these formulas and this working. Okay. Now our tan value is given as, tan theta value is given as 1. Okay. So A, B, C. So this is my theta. Okay. Now what do I do? Tan is 2, so tan theta is opposite upon adjacent. What's my opposite? side out here, which is AB upon what is my adjacent side out here, BC. But tan value is 1. Can I write 1 as 1 upon 1? Anything, or as a fraction? If it is a whole number, children, remember, if you want to write a whole number in a fraction form, you can add 1 under it. So this is 1 upon 1. That means my AB, okay, which is my opposite, is 1x, correct? It must be multiplied by some number. Okay, my adjacent is 1 again. So I need to find the hypotenuse out here. Okay, by Pythagoras theorem. Hypotenuse, which is AC the whole square, is equal to AB the whole square plus BC the whole square. What is my AB? 1x the whole square. What is my BC, which is 1x again the whole square. If I add up both, it becomes 2x the whole square, correct? My AC square is 2x. Now square root both sides. What happens? So this becomes AC and this becomes, so the square goes out, so x square becomes x. But what about 2? I'm going to leave it as it is. Alright, I either write it like this or I write it like this. Both are good to go. Alright, so now that's my AC value. What is it? X root 2. Oh, we are scared. We have a square root sign. Don't worry, children. So now I have to find sine theta and cos theta. Sine theta, how am I going to find it? Opposite. So sine is so, correct? Opposite upon hypotenuse, correct? What's my opposite? It's 1x. What's my hypotenuse? It is x root 2. X root 2. X root 2 means the root 2 is multiplied by x. So x in common moves out. So what's my value for sine theta? 1 upon root 2. Upon root 2. Not very difficult, children. What's my cos value now? Adjacent upon hypotenuse. What's my adjacent? That's also 1x. What's my hypotenuse? X root 2. X cancel. 1 upon root 2 is my cos value as well. 1 upon root 2. Getting simpler, children? My next sum. Okay. Yes. So my next sum says, let me first write down everything. Let me take theta over here this time. Okay. Alright. AC will remain the hypotenuse because it is the longest side. It is the side opposite to the right angle. What is my sine? Okay, I'll take that as well. So what is the opposite of angle A? It's BC. So this is going to be my opposite this time. And here this is going to be my adjacent. Alright, let's see. Sine means so which means opposite upon hypotenuse. What is my opposite this time? BC. What is my hypotenuse, which remains the same? AC. But my sine value given is half. That means my hypotenuse, my opposite value is 1x, correct? My AC, which is my hypotenuse, is going to be 2x, correct? So now, by Pythagoras theorem, what's going to happen? Hypotenuse, which is AC the whole square, is equal to AB the whole square plus BC the whole square. What's my AC? 2x the whole square. What's my AB? Adjacent is given, not given. So, AB the whole square plus what's BC? 1x. Correct? So, this is 4x square is equal to, see, when numbers are small, children, you can simply square them. That's not a problem. But when numbers are big, you multiply them and then it becomes difficult. Instead, use an identity in such cases. So 4x square minus 1x square, as it is changed sides. Correct? This becomes 3x square, which is equal to AB the whole square. So square root. Square root both sides, and it becomes AB, and this becomes root 3 and x multiplied. So either write it here or write x root 3. Anything is good. Alright, so my AB value is x root 3. Cool. Now what do? I have to find cos, which is where I'm going to use ka. So cos theta is equal to adjacent upon hypotenuse, which is, what is my adjacent side out here? X root 3 upon, what is my hypotenuse? 2x, x cancel. My cos theta value is root 3 upon 2. Correct? It's root 3 upon 2. Correct? And what's my tan value now? Opposite upon adjacent. What's my opposite? 1x. What's my adjacent? Root 3, x root 3. So x and x gone. What's my tan value? Tan theta value? 1 upon root 3. Here you go, children. Next sum. Okay. A, B, C, theta, opposite, adjacent, and hypotenuse. Alright, so cos theta is equal to, cos is ka. Okay, that's why adjacent upon hypotenuse. What's my adjacent? So already the value given is 1 upon root 3. So adjacent value is 1x. Hypotenuse value is x root 3. Correct? By Pythagoras theorem. Yeah. What's my hypotenuse? AC the whole square is equal to AB the whole square plus BC the whole square. AC value is root 3 the whole square. AB value not given. BC is 1x the whole square. So root 3 square is nothing but 3. Right? The root sign goes away if there's a square applied on top. Okay? AB the whole square plus 1x square. Oops, it's x. So it's going to be 3x. Correct? So 3x square, children, because the square sign will apply to the open x and apply to the square root as well. Do not make these mistakes, children. So x square minus 1x square is equal to AB the whole square. So what happens now? 2x square is equal to AB square. AB value, okay, I'm going to square root, so it's going to become x root 2, correct? So AB value x root 2, x root 2, correct? So now I have all values. So sine theta is equal to, it's going to be so opposite upon hypotenuse, correct? What's my opposite value? X root 2 upon hypotenuse is x root 3. X cancel. My value for sine is root 2 upon root 3. So root 2 upon root 3. Okay. What is my tan theta now? Opposite upon adjacent. What's my opposite? X root 2, x root 2 upon what's my adjacent? 1x, x cancel. Tan theta value is root 2. So it's root 2. Next sum. A, B, C, angle theta. So this becomes adjacent, this becomes hypotenuse, and this becomes opposite, correct? Tan theta, tan is TOA, that's why opposite upon hypotenuse. What's opposite? No, but then the value is given 21x upon 20x. So what's my opposite value? 21x. What's my adjacent value? 20. Why hypotenuse? 2r. So it's adjacent. Adjacent value is 20x. By Pythagoras theorem, AC the whole square is equal to 21x the whole square plus 20x the whole square. So 21 into 21, 1 into 1, so it's 21, 2, 4, 441. So it's 441x the whole square plus 400x square, correct? Children, as an advice, learn all the square numbers up to 30. Becomes easier. Calculation becomes faster. Every day, if you start writing it for the next 15 days, it will be at this. Your square numbers will be at the snap of your fingers. So this becomes 841x square. Now 841, square root of 841. is 29. 29 into 29. 9 9s are 81. 9 2s are 18. 18. 2 9s are 18. 2 2s are 4 plus 1 5. 1 6 plus 8 14. 6 7 8 8 41. Perfect. So it's 29 square. So AC is equal to 29x. So I get my hypotenuse as 29x. Cool. Now find my sine values. Sine theta is equal to opposite upon hypotenuse. What's my opposite? 21x. What's my hypotenuse? 29x. 21 upon 29. My cos value, adjacent upon hypotenuse. My adjacent is 20x upon my hypotenuse is 29x. 20 upon 29. 20 upon 29. Next sum. Alright. Opposite, adjacent, hypotenuse. Okay. Tan theta. Tan is 2. That means opposite upon adjacent, which is 8 upon 15. So my opposite value is 8x. My adjacent value is 15x. Right? So now by Pythagoras theorem, hypotenuse is AC the whole square is equal to 8x square plus 15x the whole square. AC the whole square is equal to 64x square plus 15 square is 225. Okay. AC the whole square is equal to 4 plus 5 9, 6 plus 2 8 and 289x square. So 289 it should be something, it's 17. Yes, AC is equal to 17x. Children, learn all your square numbers from 1 to 30. See, calculation becomes easier. Alright, so what's my AC? AC is my hypotenuse, which is 17x. Now, find my sine value. Sine theta, opposite upon hypotenuse. What's my opposite? 8x. What's my hypotenuse? 17x. 8 upon 17. Cos value, adjacent upon hypotenuse. Adjacent is 15x, hypotenuse 17x, x cancels, 15 upon 17. Next one, A, B, C, theta. This is my opposite, this is my adjacent, my hypotenuse. Sine theta means so given, which is opposite upon hypotenuse. Value given as 3x upon 5x. So my opposite value is 3x. My hypotenuse value is 5x. By Pythagoras theorem, AC the whole square is equal to AB the whole square plus BC the whole square. AC given as 5x the whole square, AB given as 3x the whole square plus BC. 25x square is equal to 9x square plus BC. 25x square minus 9x square is equal to BC the whole square. This is 16x square is equal to BC the whole square. BC is equal to 4x. It's equal to 4x. Alright? So, all my values in place. Cos theta is equal to adjacent upon hypotenuse. What's my adjacent? 4x. Hypotenuse 5x. X cancel. 4 upon 5. What's my tan value? Opposite upon adjacent. Opposite is 3x. Adjacent is 4x. X cancel. 3 upon 4. Here it is 3 upon 4. Last sum of the day, children. Alright. This is my opposite. Adjacent. Hypotenuse. Okay. Tan theta. So TOA applies. So opposite upon adjacent. What's my opposite? So this value 1 upon 2 root 2. So my opposite is 1x. My adjacent is 2x root 2. Doesn't matter. Alright, multiplication. Okay. By Pythagoras theorem, AC the whole square is equal to AB the whole square plus BC the whole square. AC not given. AB is 1x square. BC is 2x root 2 the whole square. So 1x square plus 4x square into this 2, which will make it 1x square plus 4 2s are 8x square. Correct? AC square is equal to 9x square. Correct? So AC value is 3x square root. Correct? So AC is 3x. Alright. So now sine value. Opposite upon hypotenuse. My opposite is 1. My hypotenuse is 1x. 3x. Cancel, cancel. 1 upon 3. What's my cos value? It is adjacent upon hypotenuse. My adjacent is 2x root 2 upon hypotenuse is 3x. X cancels out. So cos theta is 2 root 2 upon 3. 2 root 2 upon 3. Alright children, that's all for today. Thank you and God bless you all.